Okay, today, guys, we're going to continue what we started yesterday. Yesterday, we started to talk about the hydrocarbons, which consider the basic compounds of an organic compounds, or they are the simplest form of organic compounds, just contain two elements, carbon and hydrogen. And we said this carbon and hydrogen, they could be connected together by covalent, single covalent bond, or double covalent bond, or triple. So that's why we classified hydrocarbons into saturated and unsaturated. In saturated hydrocarbons or alkanes, we said that all carbons are connected together by single covalent bond, but in unsaturated hydrocarbons or alkenes and alkynes, we could find that carbons could connected to each other at least by one double covalent bond or triple covalent bond. So we are talking about alkanes, and yesterday we started the part how we name the alkane. So let's try to find here. Okay, last time, just are you ready, guys? Did you memorize the numbers in Latin? Did you memorize it, good guys? So number one means, anyone can tell me? Guys, grade 11. No one? Okay, that's how we could name. Okay, so we said that just one carbon. Okay, one carbon means meth. Okay, and we call it methyl because it's alkyl group. That means it's alkane lacking for a bond here. That's also propyl. While the alkane of the methyl is methane, the alkane of propyl is propane, and so on. So let's back to our lesson here, just to try to practice how to name. For example, he asked you to name the following branched compound. So he just give you here. So let's follow the steps. What the first step? Anyone remember what was the first step once we name this compound? Guys, what is the first step?
هنشوف الكاونت the
Yeah,
C
we
mini
will
C
not. Yes, we need to find the longest chain. So where is the longest chain?
the first one يعني اللي هي first
This
one
one. Yes. So that's
مم.
1, 2, 3, 4, 5, 6. So we have 6 carbon here. Also, if we count like this, 1, 2, 3, 4, 5, 6, it's the same. Well, here 1, 2, 3, 4, 5, 6 is the same. So that means the longest chain I could have ever is 6. Yes or no?
مم.
So that will be the longest chain here. So we have 6. So the 6 means the number 6 means its name is, okay. What do you call in math? What do you, or geometry? You call the hexagon, okay? So here that is hexane. So this chain is hexane. But does this hexane represent the entire compound, or we still have some branches on?
also has 3 other branches.
So we have 3 other branches, okay? So then we need to locate and find what are these branches. So what these branches, they are similar or different branches?
Similar.
Similar. All of them are CH3. All of them are methyl group. So that means we have 3 methyl groups, but these 3 located in which carbons? We are gonna count from this side or that side? We're gonna count from which side? What? Sorry, back to the question.
From the left.
From here?
أيوة.
Actually, we need to count from the side which is near to the branch. That's okay. So how much they are? So that means here we need to count from the side which is near to the branches. You get it, Tadros? That means here we have, if we count from here,
Okay.
that will be in branch 2, while it's in 4 and 5. But if we count here, that will be in 2 and 3. Get the idea?
Okay.
So we count from this side. So 1,
Okay.
2, 3, 4, 5, and 6. So like this, we have one branch on carbon number 2, and the second one on carbon number 3, and the third one on carbon number 5. Okay. So in that case, we said that 2, 3, 5, try that means 3 here. Okay, try methyl hexane, which means we have a hexane chain. This chain carry 3 methyl groups on carbon 2, 3, and 5. Is it hard like this, guys?
Okay.
Is it hard like this? Anyone can't understand?
مستر
Yes.
مستر يعني the first part I count اللي هو اللي
You
بيبقوا
find
تحت
the longest chain. You must find the longest chain. Even this chain could be branched, maybe not straight like this, okay, whatever, okay. So even if you count it like this, okay, so look with me carefully. If I just select this chain, it will not be different. There's still 6 carbons also, yes.
Yes.
So it's still hexane. And then you start to find where are the branches. You're gonna find there is a methyl group in carbon number 2, and the methyl group in carbon number 3, and the methyl group in carbon number 5, yes. Because we start to count from the side that near to the branches. Okay.
Yes.
So we are going to count from here. 1, 2,
So it will be
3, 4, 5.
trihexane.
So it will be on carbon number 2 and carbon number 3 and 5. There are how many methyl group? There are 3. So we say methyl hexane. So that's its name. 2, 3, 5 trimethyl hexane. Okay, which means the main chain is hexane, and there are 3 methyl groups located in carbon 2, 3, and 5. You get the idea?
Yes, thank you.
Is it clear here?
Yes.
Okay, so let's get more practice here, guys. Okay, so he said name the following. Let's try to do it. Okay, who can tell me how we can do it? Okay, this one. Who can tell me, guys? Let's try to work together. Tell me what the first step. Yes, Hassan.
We'll see the longer chain.
Yes,
so
where is the longest chain?
Up اللي هو فوق the 4.
This one, the R4, yes or no?
Yes.
Yes, good.
Yes.
Number 4, it means so butane. That means, yes, butane. That the R4, okay? So there is any branches?
There is one branch.
Yes.
And the third one.
No, not third. We count from the near side to the branch.
Second.
So we count here from that side. So it will be the second.
Okay.
So we
Second.
said that 2. Okay, that means in carbon number 2. What this branch called? CH3, we call it methyl. Okay.
Methyl.
So yes, sorry, that's E. Methyl. So here 2 methyl butane. Is it like this?
No, I think.
No. So here, guys, let's try to answer this one. Okay, the next one. Who can answer this? The same technique, guys. Let's find. Okay. Yes, Yasin.
We will count the longest chain.
Yes, where's the longest chain?
6.
6, yes. So whatever this one, that the R6, or this one, the R6. So any one of them, yes or no?
Yes.
Yep, okay. So like this case, we find this the R6. So 6, it means its name is?
Hexane.
Hexane, good. That's 8, okay. So hexane, that's the main. Do we have branches here?
Yes.
Yes, we have this branch and this branch. They are the same or different?
No.
No, they are different. Here we have methyl group, while here we have ethyl group because they are 2 carbons. So 2 carbons mean ethyl. Okay, 1 carbon methyl. So here that's methyl and that's ethyl. So which one must be mentioned first, ethyl or methyl? We use the alphabetic order. So E is before M or M before E?
E before M.
E before M. That means we must mention ethyl first. So that means we're going to count from this side or that side?
The closest one, down.
Down, yes. Okay, so 1, 2, 3, 4, 5, and 6. So like this, we have that the ethyl group are found in 3. So we're gonna see 3 ethyl, and then okay, this methyl found in group in carbon number 4. Yes or no?
4.
So 3-ethyl 4-methyl hexa. Is it hard like this, guys?
No.
Any hard question here? Is it clear, guys, here? Okay, so that's here how we could name the different, or that's how we could name the alkanes, or that's the steps which we follow to name any alkane. So we need to practice this more. Okay, so you're gonna find a lot of questions through internet, and then give you a sheet that contain a lot of this formula that you could name. So now we're gonna pass to the part here, which are the properties of alkanes. So what are the properties of alkanes? So actually, what is special about alkanes or make them different than the other hydrocarbons, that they have a single covalent bond between the carbons. So they have this kind of bond. Okay, so we are gonna find this bond between carbons make it that they are somehow strongly attached to each other. And also we find that the carbon is attached to the hydrogen, by covalent bond. The bond between carbon and carbon is non-polar bond because they are the same element, but the bond between the carbon and the hydrogen, also non-polar because the difference of electronegativity between them is less than 0.3. So like this, we cannot find this kind, or this they are non-polar molecules, or there is no kind of force between them. That means they have no poles in that compound. So you're gonna find here, as you could observe, CH4, C2, H6, H3, they are different, alkanes. They just increasing in number of carbons and their names. So look to the boiling point. What do you observe, guys, here? Regarding to this boiling point, what do you observe? Guys, look at the table and tell me, what do you observe? What are your observation here regarding to the boiling point? Grade 11, can you hear me?
يس يا مستر بس الصوت راح.
Okay, Todros, look at this table and tell me what's your observation regarding to the boiling point in that table.
It's decreasing.
Decreasing?
Increasing, sorry.
Increasing. So here, as you could see, the longer the alkane we have, or the more carbons found in the alkane, the more boiling point it needs. Which means increasing the number of carbons. That means we'll have a lot of bonds that hold these carbons together, which requires more of energy to be able to change it from state to another. So like this, by increasing the number of carbons, you could observe that the boiling point increases. Also, you could find that by increasing the number of carbons, you could find that this few numbers of carbons, that's up to 4 carbons, they are gaseous in normal room temperature. More than 4, up to 10, they are liquid. More than 10, they are solid in the room temperature. So here it represents the idea that increasing the number of carbons or the properties change regarding to the number of carbons which found in the hydrocarbon chain. So that's here we've said that, for example, as you can see, the physical states that can exist in the room temperature, some of them they could found in gaseous state, some of them they are liquid, and some of them can be solid. That depends on them. So for example, we could find that the butane gas, for example, that the gas which we use in our home to burn our ovens and salt, they are gases in the normal state, or they are gases in the room temperature. While you could find that the large one, the one that it could be solid like wax, for example, powder and something like this, they already they are solid in the room temperature. Here we find this the boiling point, as we said here. Regarding to the boiling point, or the idea of the boiling point, we have this kind of, we said this one we call that fraction column. This fraction column, it's used at the different or fractional distillation, the process which is used to separate the different components of petroleum, because petroleum is just a mix of a lot of organic compounds, mix it together. So if we need to separate them, we are going to work on the different boiling point. That means we are going to increase the temperature gradually within this column. So as the temperature increases, and the petroleum passes in, so some substance, for example, at 200 degrees Celsius will change into vapor. So they will pass by a pipe, or a tube to another pipe, and the others will keep moving. So the temperature increase from 250. So another one will boil and go on and keep doing like this. It's like a kind of refinery, or that we just classifying them based on their boiling point and separate them based on their boiling point. Is it clear here, guys?
Yes, miss.
I heard a question regarding to this part, guys.
No.
So like this, we already done of saturated hydrocarbons. We end of the alkanes. We know the properties of the alkane, how we name the alkane, what the alkane is made up of. Next time, tomorrow, inshallah, we're gonna pass to the unsaturated alkanes, or sorry, unsaturated hydrocarbons, the alkenes and alkynes, and we're gonna explain them in details, inshallah. So if you have any question, you supposed to ask tomorrow, inshallah. Guys, be careful. Time is passing, so please study the lesson very well. Okay, and if you have any question, I'm waiting for your question. Thank you guys and goodbye.